Today, I'm going to be taking you through an electrospinning experiment. Electrospinning is a technique that allows you to create nanofibers by applying a high voltage to a polymer solution. I begin by preparing my polymer solution. In this experiment, I was working with polyvinylpropylene, or PVP, and I dissolve this polymer in my solvent, isopropyl alcohol. I'll have to place this on a stir plate and let it stir for a few hours to ensure all of the polymer gets dissolved. The result is this viscous liquid polymer solution. Now I have to prepare my electrospinning syringe. I use lure locks to attach this thin plastic tube and needle to the syringe. I then suck up all of the polymer solution into the syringe. You want to do this slowly to limit the number of air bubbles that get into the tube. Now I switch the needle out for a spinneret. This is where the polymer solution will exit the syringe. And with that, we're ready to turn on the electrospinner. This device produces an incredibly high voltage. The red machine inside of it is a syringe pump, and this is what will push the polymer solution out of the syringe. We also have the collector plate. It needs to be covered in aluminum foil because this makes it conductive and removable. Then I will place the syringe into the syringe pump and connect the spinneret to the electrospinner using this alligator clip. This will allow me to apply a voltage to the spinneret. The voltage can polarize or partially ionize the polymer solution. This leads to strong electrostatic repulsive forces in the polymer solution at the tip of the spinneret. These repulsive forces ultimately overcome the surface tension of the polymer solution, allowing a thin charged jet of polymer solution to be ejected from the spinneret. Electrostatic attraction forces will pull the charged polymer jet towards the collector plate, stretching the polymer into thin fibers along the way. And that's how the nanofibers are formed. Before we start the experiment, we have to set some variables, including the distance between the spinneret and the collector plate, and the flow rate of the syringe pump. And then we have to close the protective screen, turn on the syringe pump, and turn on the voltage. However, with these variables, the fibers that were produced looked very bad, and they were not collecting on the collector plate. To fix this, I adjusted my variables by increasing the flow rate and increasing the voltage. And as you can see, the resulting fibers were collected on the collector plate. I removed the aluminum foil from the collector plate, and now I have my nanofibers. It's difficult to see the fibers with your naked eye, so I will have to use the scanning electron microscope to characterize the fibers and their morphology.